Hello friends, you are welcome to my YouTube channel. In this video, I'm going to be talking about logarithms, and I'll be solving some problems involving logarithms. Of course, I'll be applying some of the laws of logarithm and also exposing you to some of the laws of logarithm. For every problem we solve, there will be maybe one or two or more laws of logarithm that will be applied in solving each of the problem. So let's go right in now and start with this first one, which is the logarithm of 25 to base 5. Now, when I say base, this is the base here. This 5 is the base, while this 25 is the argument. So at times, I may be using this word argument. Just know that I am making reference to the number, okay, that you can see here, 25. So take note of that. Now, let's start by evaluating this first question, which says the logarithm of 25 to base 5. If you want to get the logarithm of 25 to base 5, ask yourself this question. This base of 5, how many times will I multiply 5 by itself to give me the argument 25? That's what we're going to do. So let's just multiply 5 by 5. What would that be? 25. And as you can see, 25 is here. So which means log 25 to base 5 is going to be what? 2. Where is the 2 coming from? From the index, because if you write 5 times 5 in index form, you're going to have 5 raised to the power of 2. So this log 25 to base 5 is set to 2 because the index of this 5 is 2. Now let me also bring you into a law of logarithm that we can use to solve this question. If you have log, say 9 to base 3, for instance, and you want to solve this question, this can be written like this: log 3 raised to the power 2. Log 3 raised to the power 2 is 9. Now there's a base of 3. From one of the laws of logarithm, let's say you have log a base b, and this a has an exponent of n. You can take this exponent to become the coefficient. In other words, you can multiply the logarithm by the exponent of a. So this can be written as n times or n log a base b. So coming back to this particular problem here, if you want to evaluate this, the 2 will be used to multiply the logarithm, and you're going to have 2 log 3 base 3. From one of the laws of logarithm again, when the argument and the base are the same, then the logarithm of that number is 1. So here, this is equal to 2 times log 3 base 3 is 1 because the argument 3 is the same as the base. So this is set to 1, and this is what? 2. Okay, you might be asking, can we do that here as well? Of course we can. This is log 25 base 5, which is log 5 raised to the power 2. Log 5 raised to the power 2 is 25, and there's a base of 5. When you move this 2 over to multiply the logarithm, what are you going to have? You're going to have 2 n log 5 base 5. And I just told you about the law of logarithm, where you have the base and the argument the same, it will be set to 1. So this is what? 2 times, all of this becomes what? 1, because the argument and the base are the same. So times 1, which is equal to 2. And it is 2 we also got here, as you can see. So I've just revealed about 2 laws of logarithm that can be used to solve this question. But if you don't want to use this one I just did last, you can just choose to use the first one I did when I said log 25 base 5. Ask yourself, how many times will I multiply 5 to give me 25? So that number of times will become the value of that logarithm. So here, since 5 times 5 is 25, the answer becomes 2, because 5 will be multiplied by itself 2 times to give you 25. And you can easily change this to an initial equation. So if you move this over here, it will become the base here, and this becomes what? The exponent, and this is set to what? This argument here, 25. This is also how you change from a logarithmic equation to an exponential equation. You see what I've just done? So I have dwelt so much on this question that subsequent question will be much easier, because I have been able to lay a strong foundation into what we're going to be doing in the next examples. So here's another example, log 27 to base 3. I am guessing that you already know what the answer would be. How many times will 3 multiply itself to give you 27? 3 times 3 times 3 times 3 is 9, then times 3 is what? 27. So you can see that 3 raised to power 3 is 27, which means log 27 to base 3 will be equal to 3. And the 3 is coming from the exponent, the number of times 3 will multiply itself to give you 27. You can use the other method where you have to change 27 to 3 raised to the power of 3, and of course this is set to base 3. If you move this exponent to multiply the logarithm, you're going to have 3 log 3 base 3, and log 3 base 3 is what? 1, because the argument and the base are the same. So you have 3 times 1, which is what? 3, and the same thing as what we got here. So you see it's very easy. Let's look at another example. So look at this one, log 25 to base root 5. Wow, this is somewhat different from what we did before. How many times will I multiply root 5 to give me 25? Root 5 times root 5 is 5, because root 5 times root 5 is root 25, which is 5. And then times root 5 won't give you 25. But when you now multiply again by root 5, let's do this together. Root 5 times root 5 is 5. Root 5 times root 5 is 5. So when you multiply 5 and 5, it gives you what? 25. So it means that root 5 will have to be raised to the power of 4 to give you 25. And I told you that the number of times that base will be raised to would be the value of that logarithm. So log 25 base root 5 is equal to 4. That's it. Where's the 4 coming from? It's coming from this one here, because if you want to write this, you can write it as root 5 raised to the power of 4. That's it. I'm also going to show you another way you can do this. Don't worry, I got you covered. So this is the other way I would also approach this question. Let's write it like this, log 25. Do you know that root 5 can be written as 5 raised to the power of 1 over 2 from one of the laws of indices? It can be written like that. So if that's the case, which means I will change root 5 and write it as 5 raised to the power of 1 over 2. And this 25 can be written as what? 5 raised to the power of 2. All right. And I did tell you before that this exponent can be taken to become the coefficient of the logarithm. So watch this now. It's going to be what? 2. Let me take this off. Log 5 base what? 5 raised by 1 over 2. But we cannot set log 5 to base 5 raised by 1 over 2 to 1, because this 5, the base here, has an exponent. If you want to remove that exponent from the base, you will have to take the reciprocal of that exponent and use it to multiply the logarithm. So see what I'm talking about. What is the reciprocal of 1 over 2? This one here. It is what? 2 over 1, which is also 2. So I'll take it out of there and take the reciprocal of that exponent, which is 1 over 2. It will become what? It will become what? It will become 2. So you multiply it again by the logarithm. You see what I have? So this is equal to what? 2 times 2 here is 4. And that's 4 log 5 base 5. What's log 5 base 5? Is it not 1? Which is, so this is what? 4 times 1, which is what? 4. Can you see that we got 4 in the previous method that I used before? So anyone you want to use is fine. Don't worry, this video will be a little bit lengthy because I want to really explain this using different methods so that you will have a full grasp of the different ways logarithms problem can be solved. Let's look at another example. This one is very, very easy because the argument is 1. So the logarithm of 1 to any base is always equal to 0. So this is equal to 0. Why? Because the argument here is 1. And this makes so much sense because if you take the base of 4 and you ask yourself, how many times will I multiply 4 by itself to give me 1? You will see that that cannot happen unless you set 4, unless the exponent of 4 is 0. What is 4 raised to the power 0? Is 1, right? So which means the logarithm of 1 to base 4 will be equal to 0. And the same thing goes for any other base. The logarithm of 1 to base 5 is 0. The logarithm of 1 to base 9 is 0. Whatever the base is, it is always 0. So look at another example. Log 8 raised to the power 2 to base 2. This is very easy, right? I already told you that you can move this exponent and use it to multiply the logarithm. So to solve this, what are you going to have? This is solution, by the way. That will be 2 log 8 to base 2. Again, you ask yourself, how many times will I multiply 2 to give me 8? You multiply 2 by itself 3 times to give me 8. So because that's the case, it means that log 8 to base 2 will be set to what? 3. Again, 2 raised to the power 3 is equal to 8. So this 8 is from the argument here. So 2 times 3, what would that give you? That's 6. So this is equal to 6. Easy, right? Okay, let's look at another example. This is quite interesting. Now we have a decimal number. Don't worry, it's also very easy. 0.125, we'll have to change it to a fraction. How do you convert 0.125 to a fraction? This will be equal to, you will look at the last digit, which is 5. What is the place value of 5? It is what? Thousandth. So you have to divide 125 by 1000, okay? And then we start breaking it down. So let's just rewrite this as log 125 over 1000 base 2. Now let's simplify 125 by 1000. You can do that easily. 125 into 125 is 1. 125 into 1000 is 8. So what do you have? You have the log 1 over 8 base 2. Now we still haven't been able to remove the fraction in the logarithm, but that's very easy. 1 over 8 from one of the laws of indices can be written as 8 raised to the power negative 1. Okay, so I'll have to change 1 over 8 to 8 raised to the power negative 1. If you do that, you're going to have log 8 raised to the power negative 1 to base 2. We now want to apply one of the laws of logarithm. Take the exponent and use it to multiply the logarithm. So what will this give you? It's going to be what? It's going to be minus 1 log 8 to base 2. Now you ask yourself again, how many times will I multiply 2 by itself to give me 8? 3 times. I already gave you another way of doing this, okay? You can even write 8, this 8 here, as 2 raised to the power of 3. And then you move 3, use it to multiply the logarithm. But I just want to make it a little bit fast. So what do we have? This is equal to minus 1 times log 8 to base 2. 2 will multiply itself 3 times to give you 8. So you're just going to write 3 here, which means log 8 to base 2 is 3. And what do you have as your answer? Negative 1 times 3 is negative 3. And this is the result you get. Let's look at another example. Okay, this is similar to the one we did just now, 0.001. Again, we have a decimal number. We are going to write it as a fraction. Okay, let's do that. 0.001, you already know how this would be. 0.001 is equal to, again, look at the last digit, that's 1. What's the place value of 1 there? It is, okay, this first one here is 10th, 100th, and what? 1000th. So that's 1 over 1000. So 0.001 is 1 over 1000, and we have base 10. Okay, again, 1 over 1000 is equal to, from one of the laws of indices, 1000 raised to the power of what? Negative 1. So that's what I will do here. I'm going to write log 1000 raised to the power of what? Negative 1, then base 10. Again, multiply the logarithm by this exponent. So what are you going to have? It's going to be what? Negative 1 log 1000 base 10. Okay, I think I'll have to use the other method. I want to have a blend of methods. So what I'm going to do is I'm going to write negative 1 times log. This 1000, if I can express it as a power of 10, which is the base here, it makes it much easier. So that will be 10 raised to the power of what? 3. but I have a base of 10. So this is equal to -1 times this 3 will be used to multiply the logarithm. So you have 3 log 10 to base 10. And this is equal to -1 times 3. What is log 10 to base 10? The argument and the base are the same. So that's what? 1. And what do you have? -1 times 3 is -3. -3 times 1 is -3. So what do you have as your answer? Still -3. We have 2 more examples to go. Let's look at number 8. So quickly, look at the base. The base is a fraction. Should we be worried? Not at all. 2 ways I'll quickly do this. Let me just be fast about this. 1/7 can be written how? Can be written as what? 7 raised to the power -1, like I explained before, one of the laws of indices. So let me just write this as 7 raised to the power -1. And what about 49? Let's remove 49 and write 7 raised to the power of 2, because 7 raised to the power of 2 is 7 times 7, which is 49. Okay. I'll move this exponent, use it to multiply the logarithm as I did earlier. So it's going to be 2 log 7 base 7 raised to the power -1. What about the -1? That is the exponent of the base. What do we do? I am going to, I told you before that if you must remove the exponent from the base, you will have to take the reciprocal of that exponent. So the reciprocal of -1 is 1/-1, which is basically -1. -1, the reciprocal of -1 is what? -1. So I'm going to multiply the 2 here, this one here, by -1. So you have -1 times 2 log 7 base 7. And -1 times 2 is what? -2. Then log 7 base 7 is 1. So I can just remove this and write 1 here. So times 1, which is what? -2. So that is the answer to that. Now, I told you that I was going to do this another way again. So let's do it another way. I'm going to rewrite the question. Log 49 is 1/7. Back to what I explained before. The number of times the base will multiply itself is what the value of that logarithm would be. So let's pick 1/7, which is the base, and start multiplying it by itself. 1/7 times 1/7 is what? 1/49. But the issue we have is that this 1/49 cannot and is not the same thing as what? This 49 we have here. So what are we going to do? How do we make 1/49 become 49? Easy. We take the reciprocal of 1/49. But let's write this in index form. I can write 1/7 times 1/7 as 1/7 raised to the power of 2. Okay? Now, if we have to take the reciprocal of 1/49, we must do the same thing to this one as well. And taking the reciprocal of this would amount to us putting a negative sign here, which from one of the laws of indices is the reciprocal. So for example, you have 1/7. This is what? 7 raised to the power -1. So you see how this negative sign is the reciprocal of 7, giving you what? 1/7. So if I dare put a negative sign to this, I will also have to flip this. So what do we have? Let's write 1/7 raised to the power of -2. This will be flipped as well. When you flip it, you have what? 49/1, or just 49. And as you can see, 49 matches with the argument we have in the question. So that's 49, which means the value of the logarithm is what? The exponent here, which is -2. So we'll come here and set this to what? -2. And this is actually what we got when we used the other method. I hope this makes sense. So let's look at the last question on this. Now, this might look scary at first, but it's actually very, very easy. How do we do this? I told you before that for you to get the value of the logarithm, ask yourself the base. How many times will I multiply the base by itself to give me the argument? If you look at this, this is 2/3. So let's multiply 2/3 and let's see how many times we will do so to give us 16/81. So 2 times 2/3, this will be what? 4 over 9, but it's still not 16 over 81. So we keep going. We multiply again by 2 over 3. 2 times 2 times 2 times 2 times 2 is 8, still not 16, so we can use that. Let's multiply again by 2 over 3. Of course, this is going to give us what we want, because 2 times 2 times 2 times 2 is 16, and 3 times 3 times 3 times 3 is what? 81, which matches with the argument. Let's write this in index form right here, which will be what? 2 over 3 all raised to the power of 4. So the value of this will be equal to 4, because 2 over 3 will be multiplied by itself 4 times to give you 16 over 81. If you choose not to use this method, let me show you another way you can do this. So here's what you can also do. Look at 16 over 81. Can I express it as a power of 2 over 3 so that the argument and the base will be the same? Of course I can. So this will be equal to what? Log 2 over 3 all raised to the power of 4, then base 2 over 3. How am I so sure of this? Because 2 over 3 all raised to the power of 4 is what? 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3, which is what? 16 over 81. So let me just take this off. And like I did tell you from one of the laws of logarithm, if you multiply the logarithm by that exponent, you have 4 log 2 over 3, then base 2 over 3. Can you see that the argument and the base are the same? So we set the logarithm to 1, which is 4 times 1, and 4 times 1 is 4, same as what we got using the previous method. I hope you got value from this video. Please support my work by liking this video, share this video to your friends and family, and of course, subscribe to the channel for more content like this. I will see you in the next video. Bye for now.